Okay? Okay. Well, hi everybody. I'm Diego, and today I'm going to talk about, well, I will talk about the history of Soy Super, and mainly I will talk about why we go the way we were. And it was, well, Soy Super is, or was, a company to track supermarket prices, and we have several tools on top of that. And that requires a lot of scraping. So for that, we decided 7 years ago to go completely event-based. So all our system is based on resque, which I ported. Was the first things I did for Soy Super was to port resque from Ruby to Perl. Right? So in our system, everything our system can do is a single task, and a task is a job on a queue, right? And it's represented by a class. For what I implemented rescue worker class that is released on cpan also, that allow us to write Moose-based workers, right? Worker classes. So it's really nice because we have parameters validation, and well, then we can do the boring part, right? In this case of sending an email. So we have a bunch of workers in a lot of boxes listening to some queues. And the important part here is it can listen to more than one queue, but the first one has the biggest priority. So if there is some shops in the first queue, it will work always on that queue until it's empty, and it goes to the second one, and so on. So we push shops to the queue all the time, and well, some worker will grab it and will run it, right? And by default, rescue will fork, so it will clean memory and it will be okay. Okay. So a simple example using this email class will be, well, to send an email. So we push that shop into the some queue, and well, some free worker will grab it and will send the email, and done. That's it, really simple, right? But of course, that won't solve our problems. But that creates an environment which is really easy to compose. So we have several workflows with a bunch of those classes, and it works quite good. We have a rule that we kind of discovered by accident when we started, that is never mix write and read kind of shops, right? So for us, a write shop is a shop that will write in some storage system, database or whatever. And a read is mostly scraping, but can be a lot of things, okay? And we discovered that because of accident, because of performance, because we cannot be opening connection to databases all the time, so it will be much easier to have the connection open and just write, getting whatever and write to the database. But also because we don't want to fork in that case, because it's too slow to write, and our tasks are really write intensive. This system, well, it worked quite good, and it allows us, without many changes, to handle around 50 million tasks a day. Okay. We have a bunch of classes to do that, and to do all kind of different tasks. A lot of workers, and we have a lot of queues. And the main topic of the talk is about how we handle those queues. Okay. So a more realistic example will be to scrape a full e-commerce website. So in this case, we will have 4 storage workers and 2 scraping workers. Okay. So we push the full crawling task. It will go to the full queue, waiting for something to pick it up. Some worker will pick it up. It will dynamically load the class to scrape that site. It will instantiate, and it will send an event saying, hey, I'm starting to scrape this. Okay? And this will go into the storage queue. And immediately, it will start sending products to the same queue. So with the time, all the workers will be picking the task, and it will be storing what this task is doing, that is scraping the site. At some point, it will finish. But the finished event will be waiting on the queue until all the other products are stored. Of course, it can completely rearrange, and it can go really chaotic, but this is how it works mostly. So at some point, some worker will pick the finished task. That is what we call a control task. Why? Because this task has all the metadata from the full scraping. So this worker can control if all the other tasks has finished. In this case, it didn't. So it will be repushed to the store queue until finish, and it's done, and that's it, right? Most of our workflows are not that big, but between 5,000 to 500,000 tasks in one workflow of this kind. And after this, it can push another thing to do after this task, and well, it can be really complex. And again, it works quite good. It worked that good that at some point we decided that we will make a business on top of this. So after, not only will start scrapping for us, but also for others. So we changed it a little bit, and we started to do a lot of scraping for clients, right? So we started to add a lot of new targets, right? And with each target, we had to add more queues, because we separate workers on queues. And we started to divide in priorities, because the tasks that we need for Soy Super, for the primary objective of Soy Super, were really needed to be real time, but the others can wait a little bit. So we divided in separate priorities. Also, we need to make sure we separate load between IPs. So we also use queues to make sure we have workers listening to each queues on different IPs. And we have to make sure we have all the time some workers available to pick new shops. And we have to make sure we are not disturbing the website. We are not being a bad player on their side. So we need to make sure we don't paralyze too much. But sometimes we go wrong, so IPs get blocked. So again, we need to change and reconfigure our queues. And by the time when we started to grow, well, all our distribution of queues were mainly manual and done by Ansible. So every time we need to add a new queue or reconfigure for any reason, we have to manually touch YAML files and say to our deploy system, hey, again, redeploy all the workers. Okay. Still, it worked okay. Well, not that okay. It was really problematic at that time because, well, manually editing YAML files that were growing a lot was really problematic. No one wants to do that. And also because every time we redeploy all the workers, long-standing tasks will be shut down and we'll have to restart. So that was really problematic. But we were growing a lot on this new side of the company. And we were adding more and more targets. And we, at some point, we standardized the system and we make much easier to add new targets. But still, we were deploying manually. And we growing and growing, and a lot of queues. And Ansible was the big problem here. But we were too busy to fix the problem. So we were keeping on, until one day I sat down with my coworker and we say, enough, we need to solve this thing. It's impossible to go on this. So we decided to start thinking about what we can do. And there was no many ways to go. There was probably one way to go. That was remove the Ansible files to reconfigure all the workers. So we need the workers to be able to somehow reconfigure itself, right? Well, so we need to move from this situation where all was set on stone to this situation where our deploy system will just say, okay, this box has to have, I don't know, 3 workers or 6 or whatever, but the worker has no queues. So then we will have to have one new system that will say to the workers, hey, this is your queue. So the worker will have to ask, right, and get the queues. And from time to time, re-ask and get the new queues, okay? And finally, if we have this, we will have our automation system talking with that service. So I sat down one Friday morning with this idea in mind, and I saw the code in Resque. And this is the code that does most of the work on a worker on Resque, right? So we were thinking about it for a long time. We were thinking that it will be really problematic to implement this thing. But when we saw this, it was really easy, because just adding here a callback, it will allow us to reconfigure the worker, okay? So we added this callback here, we release it, and we start using it. So our custom worker, we added a piece of code that will get information for the worker, okay? It will get which IP it's going out at that time, which country, which city, and a lot of information. Then it will debounce, because we don't want to go to the system all the time. So we are going about not more than once per minute. And then we will post the information to the brain. We call the system like the worker brain. So every time we say, hey, I'm here, I have this IP, I'm going out from this country or whatever, the brain will tell us which will be our new configuration, okay? And this will happen, as we saw, every time the worker is waiting for new shops, okay? And that leads us to the hardest part, because this was really easy. It was done in probably 2 hours. We knew that the idea was working and it will work, but having a service that doesn't know anything about workers decide what the worker has to do is not that simple. So we sat down with my coworker. We sat down for the whole day, and at the end of the day, we kind of have a class that can handle most of the situations with a lot of tests and that. And it was base rule, so we give to it a lot of, like, we use units. Each unit is a target, and it has a set of rules that it has to follow for that target, okay? And that rules can be which queues it has to listen to. It can be minimum and maximum amount of workers it has to have. How many workers can go out using the same IP. The IP binding stuff. Prevent. We have some units that we have to make sure that never go out using the same IPs, okay? Because they belong to the same provider or stuff like that. Also, we can say, I want this unit to go out using IPs of France, for instance. Also, we can say the priorities. I don't care if this unit goes second or third or whatever in some queue, because there is not a big priority. Or I want to make sure this unit will never share a worker, because I want to be really responsive. But the thing was that it has to decide all the distribution of workers on each change. So every time the worker receives a new message saying, hey, I'm here, this is my host name, this is my IP, whatever, it can be a new worker or an old one. And sometimes workers can go out and disappear, and it has no notice of that. So the system has to be kind of rebalancing all the time, okay? And trying to reach the best distribution. And for that, what we did, it's really simplistic and it works quite good, is we give like points for the requirements of each unit, and all the time it's like sorting on that points and assigning to the one that has more points. And if it allows secondaries, not only to the first one, but to most workers, to most units. And it was great because we have a single source of truth where all automation can go and reconfigure stuff or read, and we know, because this is really very dynamic, so now we can go to this system and ask, okay, I want to know which units are working where, or I want to know, well, whatever is always in that API. So this worked really good, and the next thing that we set to do, but this was about 1 year ago, we had to fix a lot of bugs in the brain, but nowadays it's working quite good. And well, probably we should have, we can improve the auto balance stuff. It still is working and it's growing a lot. Like we are adding probably from 1 to 3 units per day. Some, well, it depends. It works quite good. It's a single point of failure. It's not really a big problem, because if this API goes down, all the workers will stay with the last configuration they got. Okay? But we cannot add new ones if it goes down. So we need to solve this problem. At this time, the only thing we can do is take backups of the units, of the configuration of the units. Also, we are handling like time-based banning, but we are handling it outside of this application. So there is our automation or bot that is handling this problem, and when something happens, it will talk with this API. And so we are thinking that probably it can be automatically handled by the brain. So workers will inform to the brain, hey, I got banned on this IP, please ban it for 6 hours or whatever. And since then, we have only moved all the scraping tasks here. But our system is all based on this rescue system. And we have a lot of other tasks that can be moved to this system to offload the Ansible stuff. And I think we will start moving a lot of stuff because this is working quite good. And that's all. It works. Thank you. So I know, is there any question? Nope. Yeah, I saw it. I think we are not, but I'm not sure. But we are relying on an external service, yes. Why? Oh, yes, sure. But yeah, but if that breaks, yeah, it will be a problem. Yes, sure. Yes, our problem was, oh yes, the question was if that I said that we had problems with Ansible scaling. And the answer is, the problem wasn't really Ansible. I mean, we still use Ansible. We don't love Ansible, but we still use it. But the problem was the way we were using Ansible, not Ansible itself. So what we removed from Ansible was the dynamic part. But yes, the workers are still deployed by Ansible. Yeah. Yep. How do we detect? Oh, we don't. I mean, yes. Okay. The question was how we detect time-based bands. Well, we don't. I mean, or when I say that we configure units, each unit has its own driver. So the driver is the code that knows about that target. So that code is the one who will know if that's that website does time-based or not. The time we discover that is try and error. Yeah. Yes? Nothing. The question was how much load does the worker brain API support? It's really low maintenance because everything is in memory. I mean, the brain is in memory, and it's a single process, async, sharing the memory. And the only thing it does is every 1 minute, something like that, it flashes to disk. And it's this library plus 20 lines of Mojo code. It's really easy. And we use a lot this technique of having small services without database, where the database is memory plus disk. Any other question? No? Well, thank you. Yes? Okay. I have a few more. Since then, I was working in a new piece of code. It's not released yet, but probably will get released when I fix a lot of bugs that still has. And I don't know if you know Minion, but Minion is a really nice project to handle shop queues on top of Mojo. And I would love to use that, but well, we are really invested in Resque now. So I would like to have something to replace the way we deploy workers now. The way we do it is we use Ubiq to keep the workers running, right? So I want to have a supervisor like Ubiq with more visual interface, okay? Focus to rescue. By the time it's really focused on our use of rescue, but the idea is to make it more general. So it will be a web application that can run workers, okay? So this is how it works is it's a Mojo application that will fork workers, right? And will keep those workers running. Yes? And it has an HTTP interface on top of it. So we can have several of those talking each other, okay? And you can connect to any one of the nodes. And all the nodes are completely independent, but knows about the other nodes, okay? So when you go to one node, you will get information from all the cluster, right? So you can launch new worker, stop, pause, whatever that you can do with Rescue, will be able to do it with this interface. And I'm working on a client that's based on React. Probably I will move it to Vue because I'm quite crappy doing JavaScript. And this is how it works. It allows you to see all the workforces. It shows you or share data we have. That's why it's focused on our usage. And it shows you what each box is doing, each worker is doing, and also you can pause, you can start, and you can stop new ones. And that's it. Thank you. And I expect to release.